In a surprise breakthrough, a next-generation open-source AI model named Zeroscope has been released with the ability to run state-of-the-art text-to-video on modern graphics cards. And as a byproduct of China's ModelScope, Zeroscope aims to redefine both video and media by enabling 3 brand new categories of digital experience. But first, what makes this AI stand out as such a game-changing text-to-video model anyways? The secret lies in 2 key components: Zeroscope V2 and Zeroscope V2 XL. Impressively, these AI models equip users with the power to create and upskill video content from text with unmatched quality. In fact, the V2 model offers a rapid content creation gateway, exploring video concepts at a resolution of 576 by 320 pixels, while the latter V2 XL model takes the concept further, providing an avenue for upscaling these videos to high definition at a resolution of 1024 by 576 pixels. Furthermore, Zeroscope's requirements are surprisingly manageable due to the multi-level model's 1.7 billion parameters. Under the hood, the AI operates with a VRAM requirement of 7.9 GB at the lower resolution and 15.3 GB at the higher, both at a frame rate of 30 frames per second. Therefore, the smaller model is primed to operate on many standard graphics cards, making Zeroscope an accessible tool for many content creators. At the core of Zeroscope's training is the strategic application of offset noise on almost 10,000 clips and almost 30,000 tiled frames, each comprising 24 frames. This seemingly odd choice opens a new world of possibilities for Zeroscope. By introducing variations like random shifts of objects, slight changes in frame timings, and minor distortions, the model improves its understanding of the data distribution, allowing it to generate a more diverse range of realistic videos and effectively interpret the nuanced variations in text descriptions. Interestingly, Zeroscope might become a worthy open-source contender for Runway, a commercial text-to-video model provider. Also, Zeroscope's developer Suspense says it's not super hard to fine-tune a model with 24 GB of VRAM, and he defines this model as being designed to challenge Runway's Gen 2. Even better, Zeroscope is entirely free for public use, and if you're intrigued, both the Zeroscope V2 and V2 XL are up for grabs from Hugging Face. Plus, there's a version with an accompanying tutorial that's also accessible via Google Colab. But text-to-video technology, however, is still toddling as AI-generated video clips tend to be short and laden with visual flaws. However, early image AI models faced similar challenges before quickly achieving photorealistic quality. The caveat is that video generation demands significantly more resources for both training and generation. Despite these constraints, the progress in the text-to-video arena is noticeable with Google's Phenaki and Imagen, plus Meta with Maker Video, having already showcased these text-to-video models as being able to generate high-resolution, logically coherent clips, although these models are yet to be released for public usage. As of now, only Runway's Gen 2 is commercially available, having also found its way to the iPhone. However, the advent of Zeroscope as the first high-quality open-source model is signaling a significant milestone, and in terms of the future, generative AI like this stand to enable the emergence of 3 brand new digital experiences to dominate player preferences from this point onwards. Number 1. Personalized gaming, VR, and metaverse. In the sphere of video games, Zeroscope's text-to-video transformation capability could redefine storytelling mechanics. Imagine a game where players can dictate the narrative using their words, influencing cutscenes and gameplay in real time. This could enable a level of interaction and personalization never seen before, bringing the concept of player-driven stories to life. Moreover, game developers could use the technology to rapidly prototype and visualize game scenes and assets, accelerating the development process. Number 2. Personalized movies. As for personalized media, Zeroscope's technology could disrupt the industry by creating individualized content based on user descriptions. A user could potentially input a storyline or scene description and have a personalized video generated in response. This not only encourages active viewer participation, but also opens up unprecedented avenues for custom content creation. Personalized video advertisements, user-tailored movie scenes, or uniquely crafted music videos could all become part of our media consumption experience. Number 3. Synthetic creators. Entering the synthetic creator era, Zeroscope might be paving the way for a new generation of creators that rely on AI to write, produce, and edit their ideas into reality, removing the barriers of technical skill sets in video creation. Furthermore, Zeroscope's potential in AI-based virtual production could establish a new standard for automated, high-quality video content, ushering in a new age where the line between human and AI creators blurs, widening the landscape of creativity. Meanwhile, an equally groundbreaking model called Snapfusion has just been released to perform text-to-image diffusion almost instantly on mobile devices. And when it comes to generative AI methods, diffusion models have unquestionably emerged as a linchpin of the revolution. Their applications include producing lifelike images from textual cues in a blink, reforming image modification, high-resolution enlargement, video synthesis, and even 3D asset production. However, the high computational demands of these models have confined them to high-end GPUs and powerful computers until now. But Snapfusion solves this, as the pioneering text-to-image diffusion model enables mobile devices to generate images in less than 2 seconds. This gives anyone with a device the capability to render detailed, photorealistic images directly on their handheld device, overcoming the conventional boundaries of mobile processing power. The creators of Snapfusion took the U-Net architecture, the backbone of the conditional diffusion model, and injected a dose of optimization to accelerate its speed, making it apt for mobile use. Pre-existing models focused mostly on post-training enhancements, whereas Snapfusion brings a fresh perspective, identifying and resolving architecture redundancies through an evolving training framework. The Snapfusion team first explored the architecture redundancy of ST 1.5, but ran into difficulties when they found that alterations to the structure could cause performance degradation, necessitating time-consuming and resource-intensive fine-tuning. This challenge led them on a new path to develop innovative solutions that maintain the efficacy of the pre-trained U-Net model while progressively enhancing its efficiency. By executing each cross-attention and ResNet block with a particular probability, Snapfusion introduces stochastic forward propagation during the robust training phase. This significant development ensures the network's tolerance to architectural adjustments, permitting precise assessment of each block and securing a stable architectural evolution. Another significant achievement of Snapfusion lies in its data distillation pipeline that compresses and accelerates the image decoder, all the while preserving high-quality generation. This pipeline uses synthetic data to train the reduced channel decoder, creating an efficient image decoder with significantly fewer parameters than ST 1.5 and at a faster rate. The step distillation technique proposed by Snapfusion introduces a unique vanilla distillation loss objective. This innovative objective seeks to minimize the discrepancy between the student U-Net's predictions and the teacher U-Net's noisy latent representations. To further improve the CLIP score, a CFT-aware distillation loss objective is introduced, implementing CFT-guided predictions in both the teacher and student models. And what does all this intricate optimization result in? A pocket-sized powerhouse that can create 512 by 512 pixel images from text prompts on your mobile device, and in 2 seconds or less. Snapfusion does not compromise quality for speed or size. The generated images are on par with those produced by the state-of-the-art Stable Diffusion model. Snapfusion isn't just a significant leap forward in applying diffusion models. It's a monumental step towards making cutting-edge AI accessible to everyone, right in the palm of their hand.